Okay, so we have started. All right, let me just admit myself. Okay, there we go. All right, excellent. Okay, so it's 2012. Kind of disable the waiting room. Okay, and what I want to do. All right, welcome, Patrick. Welcome. Can you hear me? All right, good. Welcome.
Okay.
How you doing today?
Good.
All right, good. So we're on our final topic on the cycloids. Remind me what was the first thing? We drew a cycloid on a straight line, correct? Trace the path of a point on a circle on a straight line. Remember that? All right, I'm guessing you do. Then after that,
Wait, with that answer?
yeah. So the first thing we looked on about on the cycle was to how to draw the path of a point on a straight line. You remember that? Where we got a curve. You remember?
Kind of.
Let me screen share. Let's go back quickly. Go back to cycle. Okay. The first thing we learned, so to draw, and this is on the YouTube page for Heinz, right? Drawing the path
Oh, circle.
of a circle on a straight line. Here we go, right here. This was your first project you did. You remember this? If you don't remember it, that means you didn't do the project. So that means you have this to do. It means you weren't there at that class. So you need to get this done. The video is already made. Technical drawings, Cena 5 Cycloid plus setting up AutoCAD. That's the first thing we did.
That explains you the complete thing, sir.
Exactly, exactly. It's 14 minutes long.
So one, so if I do the video, I finish the project.
Exactly. And any issues you have, just
Oh,
message me. So let's go back, go on the Heinz YouTube page and look for this video. It's in a playlist called Technical Drawing S5.
Where do I do like all my house cat work?
Right.
Like, is there a specific page?
So here's what you do. Let me show my screen. All right. When you're doing AutoCAD work, you don't have to have multiple files. You can have one file with all different drawings in there. So see how I did parabolic?
Like the one that did my test on, I can do everything that.
Exactly. You can just continue on the same file, so you never have to remember, well, where did I save X and Y, right? Because no, all I'm gonna do, I'm gonna move over and I'm gonna talk about hypercycloids today. Understand?
Yes.
All right, good. Now, if you remember that cycloid was really just plotting the points on a straight line, hypercycloid takes that to another extent. Let's look at what hypercycloid is. Let's go here.
Wait. So was my isometric to orthographic projection good?
Um, Isometric to for the exam.
Orthographic. Yeah.
Um, it it was good in the sense that you did get the major aspects of the drawing, but in terms of securing the most marks, your lines types weren't effective, and you missed a hidden detail. I think I went through it last class. Let me quickly go here.
No, I did put the hidden detail. It's just like, oh, you mean on the isometric drawing, or what's that necessary?
Yeah, on the isometric drawing. So you got 85, which is good, which is good. So let's look. You lost one mark for types of lines, and you lost another one for the different aspects of the drawing where that you missed. For example, the construction box, you lost a mark there, but that was good nonetheless. And for the first one, the sketch, you did it excellent, but you lost 3 marks for not using the Cavalier 3/4 that I mentioned.
Well, what is that?
All right, we'll go over it when we're going through oblique. Essentially, what Cavalier 3/4 mean is that whatever measurement you have, for example, 18 millimeters, right? You multiply it by 3 divided by 4th to get how it would look in oblique Cavalier. So, for example,
Oh.
you forgot it, right?
Oh, okay.
Yeah. So that would be Cavalier 3/4 that you should have done for the measurements. All right, let's go
So
back.
the number times the 3/4.
Yeah, number times 3/4 for all the angles that going backward. Afternoon. Right, so let's get started today. So I just recapped what we did for cycloid. and I'm gonna show you what we're doing today, which is hypocycloid. Most likely we're not gonna be able to finish it, but I will start it, and your task will be to finish it over the weekend. No, if
Also, sir,
yeah,
after class is finished, can you help me with the dimensions thing again?
no problem, no problem. So I was just mentioning to Patrick, if cycloid was you drawing the path of a point on a straight line, epicycloid was you drawing the path of a point above a circle, what would hypercycloid be? Drawing the path of a point below or above?
Could you repeat again, sir? I don't understand.
Alright, let's go back. Hypocycloid is drawing the path of a point on a circle that is inside of another circle. Alright, understand? So let's try to mentally assess this. Here's the point. It's the circle is moving inside of another circle, and we're tracing the point of the path of that point as it's going around it in a revolution. I'm asking, well, so why is this applicable? Why do I need to know this? Simply, I know you guys are asking that. If you are even interested in doing an engineering subject, like a car engineer or mechanic, right? You know that he has moving parts, and in those parts you need
Like
to
the engine and
right
yeah.
camshaft and so forth. This is essentially what they use to predict the movement of all those points so they never collide. You predict the path of it. Right? So that's
No,
what.
sir. Makes
Welcome.
sense. Makes sense.
Welcome.
Makes sense.
All right. So that's why you might be asking, well, a car engine can go 500 revs per minute, but it never touches the other opposite end of it because it traced the path of it to the finite decimal. All right, so it never collides. All right, and that's what we're gonna go through today. So quickly go on your AutoCAD. Here we go. And then typical question started off with saying that you got a small circle. We're gonna make it, for example, in this one. Let me go on my construction layer. All right, here we go. And to turn down, another quick tip: if your construction, oh my bad, if your construction layer is in white and you don't want to turn it gray, you can go here and just turn on the transparency, how bright it is. Let me show you. 1 second. Alright, I don't know what's happening there, but yeah, let's draw on our construction. Here's my construction layer right there. Alright, let's draw a circle of. Let's go back to the video right here. So watch this with me.
Next curve.
Fast forward. So here's the path. A hypercycle is a curve traced by a point on the circumference of another circle without slipping on the inside of another circle. Right? So here's the path generally that we want to obtain today. Right? Same as what was discussed in the GIF a while ago. Or is it GIF or GIF? I don't even know. That's the path we want to get. This curve right there. Right? Alright, so the method for construction of hypercycloid is the same as epicycloids, but the opposite is done where beforehand epicycloids was on the outside of a circle, now you're doing the path inside. Because the path was overstep, now we're going to go under. Alright, it's the same formula. What was the formula again to get the angle? Anyone remembers?
No, sir.
Formula, it involves...
Isn't it 0 times R?
Right, R
Times 360.
Perfect. I'm glad someone remembers. That's the formula to get the angle. Right? So if they gave you the small r, which is a circle that is rolling, as something that's 25, and the big R is 75, it would be 25 divided by 75 times 360. That would give you the degrees to which that is rolling. Let me explain. Let's go here back. Alright, 1 second. Alright, here we go. So now we're going to calculate the angle to which the extent of that path is traced. Right? So in this case, we're just going to use a simple basis of 50 as a small r and 75 as a large. Same step as previous. But instead of having the center be above the point, like the epicycloid, the circle is now going to be underneath the curve. See the difference? Because beforehand the circle was above the point, correct?
Yes, sir.
But no hypercycle are just saying that, well, we don't want to know the path of a point outside of a circle. Let's see how it looks on the inside. Hence this. Alright. So let's begin to trace our point. Let's go here. Alright, so we're gonna draw a small circle. We're gonna plot out our line, any angle. But let's just say, for example, this is gonna be 75, right? Plus 20 plus 50. There we go.
Oh, so you just created a line, sir?
Yeah, here we go. So here's a line.
And what measurement is that?
Right, so the first measurement was the distance of the large radius, 75. The second line, distance of the small radius, 50.
Sorry, I'm signing.
All
I
right?
don't want to get left behind.
All right, no problem. Hurry up. So meanwhile, while everyone is loading up the article, I must continue to play this video.
Sir, it keeps coming every time I make a new drawing. It uses the template. Is that okay?
I was explaining to Patrick when he joined that you don't have to have different different files for every drawing. Here's what I'm
You
doing.
can have one file for everything.
Yeah, so look at this. My parabola that I did yesterday, last class, is literally just right beside this. So I always have all my files together. Then now when I want to export one, I just zoom into it. So you should try to use one file. Because look at my title, everything. Right? I never have to worry about where everything is. Alright, let's get back here. So now, let's quickly annotate where exactly our point is. And I told you that you can use donut. Right, so I'm going to go on dimension layer. Dimension. And I'm going to select a donut. Specify the inside as 2 and the outside as 5. Remember? Then you go to where the...
Wait, sir, how long is that line again?
So it's going to be 75 for the inside circle. 75 millimeters. Then you extend to 50 for the next circle. Alright? And since we know that's going to be 120 degrees, because we're just using the one that's on the video, you can just draw the horizontal line now, because that will make us have a 120 degree. But we can't draw the line because we don't know the distances yet. Alright, so what we need to do, let me play the video. Here we go. What was the step we said to get the rolling circle? We essentially need to use the point C to O, right, and create that curve to represent the circle. Let me explain.
Sir, is that supposed to be a specific angle?
Yes, it's supposed to, because remember you're using the formula. But we're saying that since we know that 50 divided by 75 from Hypocycloid gave us 120, we're just using back the same 120. But in your questions, for example, it could have been 80 divided by another large number like 140. Then that will give you a different angle. Let's calculate that. Let me see. 80 divided by 140 multiplied by 360. That would have given you an angle of 205 degrees. But we're using 120 degrees for oil.
Okay, so 120 degrees and 75.
Right? And then you extend that 75 an additional 50. There you go. So after we've done that now, we essentially can draw our first circle barrier. Let's put it in construction. What's the construction layer? Well, yeah, construction. Using the point here as center, draw the arc. Just zoom in a little bit and figure out where exactly it's touched. There you go. Excellent. Excellent. Let's draw a horizontal line now to connect. I'm gonna say line. Alright. And if you were to measure this, let's measure the angle. Measure angle. This would be 120 degrees.
Sir, my 120 doesn't go that way. It goes the other way.
Do you have on your snaps these settings? Alright, and then you go on polar tracking, select your increment as 30.
It is 30.
All right. There's another trick to get your specific angle, and I was hoping I didn't have to teach you this because it's gonna confuse you a little bit. But here's what you do: you're gonna select your line, for example. Just select line, press a point, press tab, tab.
I know.
Sir, this is the push.
All right.
So how long was the line?
It's 25.
35?
75.
75. So Jessica,
Tab one.
if you can't get the angle, here's what you do. Follow my instruction. You press anywhere for the line, and then you press tab. The tab button. It's gonna ask you, well, how much do you want your angle? You're gonna type in 120. There you go.
See, sir, that's what it did. That's what it did. But yours is the other way.
Oh, I get you. I get you. Your orientation could be anywhere really, because as long as angle between it is 120. So, do you remember what quadrants are? Remember that you have really 120 at every 90. So you just have to really try to understand that 120 here would be the opposite here. So you could just extend it. All right, but let's get back. All right. So after we've done that now, we've almost completed what we need to do. But let's go back.
Wait, sir, after I draw the line, what do I do? After I do the other 52?
You're gonna detail that the point CO is gonna be your first circle, such as the one I draw right here. See it?
But we will find the midpoint.
No. You would just extend a circle using this center point to 75. And we can draw the next circle.
Wait, that's center point of 75?
Yeah? So here's what we're gonna do next. We're gonna extend, because remember, this is the extent to which the entire line is 75 plus 50. We can draw another circle, right, to enclose the hypercycloid. Huh? And we can extend the line now. We can say extend this line to touch.
Wait, how big is it? How big is the circle supposed to be?
125 in radius, because that's 50 plus 75. Right?
And how long is the line supposed to be?
Repeat.
How long is the other line supposed to be, the horizontal one?
This is gonna be 125 as well.
So you said the radius should be 125?
Yeah, for the large circle that covers everything.
Oh, sir, so for the first circle, how much should that be? How much should that be?
This circle?
Yes, sir.
75.
Okay.
Right?
Wait, I'm confused. So I draw the circle from the center.
Yeah, this is your center point at all times. That's why I'm saying it's important to label, but we can do it after. Yeah, because when you label now, you can call it like point O. But this point is gonna be the center point for all of your circles right now.
Okay, so the next circle, the smaller one, how much is that?
This one's 75. All right, let me get a moment.
Okay, alright. Now I'm where you are.
All right, good. Follow along with me.
I'm done.
So now using the center point from 75, we're gonna draw a circle to extend to the point P. Let me explain. So we're gonna use this.
Okay.
Gonna use this point and draw a circle to extend to the point P. Here we go. Center circle. Center point here. Draw a circle. 50 millimeters in radius. Here we go. Okay.
Okay.
All right, good. This is the fun part, but again, you'll have to do that after class because it's going to take a moment. You're essentially now going to label each point, but let's just quickly trim up what we don't need. All right, so look at the video for me. This is your main point that you need, as well as your center. So you're going to create now another point. Using this, go to the center point that we did earlier, and label that as your center line. So this line is going to be called our center line. So what you can do to trim it, select this line with me and this line, then type in the trim command, TRIM. There you go.
Sir, what was the radius for that small, the circle that's gonna roll around?
50. Alright?
Oh, we weren't supposed to trim the big circle?
Yeah, you can trim it. You can trim it. Just haven't done that yet. Let me trim it. There we go. Excellent. There we go.
Should I label it while we're waiting?
Alright. Now, I did the same thing last week and no one corrected me. Alright? Now I want to see, can you guys realize the mistake that I made again? What was the mistake that I made this time? No one answered, and I gave the answer last week. Let's read the question again. Let's go back to the question. Draw a locus of a point P on the periphery of a circle. Take the diameter of a rolling circle as 50. Exactly. So that means that the 50 would be 25. I was hoping someone would say, no, sir. Last week, remember we explained that this diameter is 25? Alright, so we need to correct this. Go here. So we're going to say 25 millimeters from point P will give us our circle. So you're going to extend, so you're essentially going to do this for me. Go here. Go down 25. 25. There you go. And this is going to be your circle for the rolling circle. There we go.
So you can do that again.
Alright, let me go back. Alright. With me? Alright,
let me trim that.
It says, take the diameter of the rolling circle as 50. Alright? If the diameter is 50, what is the radius?
So I can't find the center point that you used right there.
And it would be 25.
Exactly. So that's why I was hoping someone would say, sir, the radius is 25, not 50. So what we need to do simply, look at this one, Jessica. You can do a simple command, because this should be a single line, because remember we sectionated it. So we're going to say the midpoint here will be the center of our rolling circle.
Sir, I think I did something wrong.
Alright, so let's follow along with me then.
I did the 50 at the bottom instead of...
Oh, there you go. There you go, there you go. That's the issue. So let me draw back the circle quickly. Alright. I'm going to go 25 in. 25 in. Now the diameter is 50. Because before the diameter would have been 100.
So, sir, what's the length of the outside lines?
The length of this line?
Yeah.
The length of this line would be the radius of 75 for the circle, for the big circle, plus a diameter of 50. So the length totally...
I think looks like yours, just the other way around. Like if you mirrored it.
I got you. So basically you had a 50 below than above. I got you.
Yeah, but like my drawing is still like the other way around than your drawing. Like you see where that circle is? Like if you twist it.
So over here. Yeah. Yeah. Not to worry. It's the same steps. Same steps.
Okay.
Yes, the same steps. Alright.
Sir, what that radius of the circle have to be?
Radius is gonna be 25.
25.
Yeah, and then the large radius would be 75. Alright?
Oh, I understand now, because I was confused.
Alright, good. Glad you got it. Glad you got it. Follow along with me.
Sir, can you see my screen?
Wait, Let me look at your camera. One sec. Yeah, I can.
Share screen, but
Yeah, yeah, I can see it. Right. That's correct. That's correct. That's correct. All right. Now we're simply gonna do the same steps as before where we divide. So let's just quickly do that. We're just gonna say we're gonna draw a line. That's the radius line. So we're gonna say line from the center of the circle to any point, right? And then now we're gonna polar array. So follow very carefully. You're gonna select the line from the radius that you just draw. You're gonna go and look for a polar array right here. Alright?
polar array.
Yeah.
Command.
But is that line supposed to be a straight line, or is it supposed to be like going at a specific degree?
It can be a straight line, just from the center to any point under the circle. Alright?
I can't find polar array, sir.
Alright.
It's array polar.
Yeah. If your thing is gonna be array polar.
Now what do I select, sir?
You select that radius line that you just draw. Select it.
Yeah.
Press enter. Specify the center point as the center of the circle. Then now you're gonna type in, let's do 8 for this one, because we've been doing 12. Let's do a simple one of 8. So you're gonna go to the top.
I got lost.
Wait.
So when you get the array polar circle, right?
Yeah.
You select the circle.
No, select the line, the radius line that you just draw, because I said you're supposed to draw a radius line. So look at this for me. We're just gonna go from the center of the circle and extend the line any point on the edge. Let's say, for example, here. There we go. Right? Then we're going to type in array polar. Select that line that we just draw.
Yes.
Press enter. Specify the center of the circle. Bam. Now we're going to change the items above here to 8, not 6. 8.
8?
Yeah? And then press enter. There you go. Alright, good. Step 1. Step 1. Next thing to do is to divide this arc into 8. So we're going to just type in divide. Type in 8. There you go. Then you go on P type. If I'm moving too fast, let me know. Then you just change.
Wait, divide? And what do you select when you first divide the object?
Yeah, the outer line right here. Right?
And then after that.
Yeah, it's going to divide it into 8.
P type?
Yeah. Yeah, P.
8, then enter.
Yeah, then type P type to enlarge it. Because if yours is small, just put it as a larger size. But if it's okay, you don't have to change the size. There you go. Then
what's the keyword or option?
Forward.
Yeah.
What's that? When you alright, so when you press divide and select the object, what do you do after?
It's gonna ask you how much division do you want. So you're gonna select 8.
Oh, okay.
Yeah, and then now you should have your points looking like this. If not, let me know. But what you're gonna do now, Jessica, you're just gonna connect those points to the center of the circle. Let's do that. So we're gonna go in D settings. We're gonna look for node. Turn on node. Alright, let me know when you're done now.
Connect all those to center.
Yeah, it's gonna add them, and then that will be it. Let's quickly do this.
So after you get the. So what's the measurement of the bigger circle again?
Yeah, it's gonna be 75 in radius. So this is the biggest circle. Here we go.
Yes, sir. So when you divide the outer line and you get the points, what's the next step?
One moment. Okay, so after you divide the outer line in 8, it's gonna connect all the points now to the original center right here.
So just connect them?
Yeah, just connect them. Right. And I'm gonna ask you one more question, and let's see who is paying attention. Because alright, I did something and I want someone to explain to me why I did it. So quickly the question after you connect all of them. Not gonna be hard, trust me, it's not gonna be hard.
All right. So you said press what do you call it? To node or something like that?
Yeah, so we're going let me do it again. Go in D settings, these settings, and then you go on under object snap and you look for node and turn it on. Alright, now we're gonna pause for a second because this is basically the same thing we've been doing in Cycloid and Hypercycloid. But I'm gonna remind you, what was Cycloid? You draw the path of a circle on a straight line, correct?
Part of a circle and a straight line.
You remember the Cycloid where you just draw a straight line and put the circle at the end? You just draw the curve?
Yes, sir.
Right? That was Cycloid. Epicycloid was what? When you drew it above a circle, remember?
Yes, sir.
Right? And I just said hypercycle is when you draw it below. Let's go back to the diagram. And I was wishing someone would say, sir, hold on. Let's look at the diagram again. So you're drawing it below, under the rolling circle. Is this above or under the rolling circle? First of all, what is the rolling circle? What is the rolling circle? Is it this? Or
yes.
So this is the rolling circle, right?
Yes, sir. Yes.
Is this above or below it?
Above.
So is that a hypocycloid? No.
Brush.
Look. Hypocycloid is below. So all we would need to do is to put this circle underneath the rolling circle. I was hoping someone would tell me. Here we go. So all we're going to do is select the circle and the divisions and type move.
Patrick said the thing kicked him out because he's having Wi-Fi issues.
Alright, no problem. Tell him I'm recording it, so I'll just send him it. I'll edit them over the weekend. The parabola, this epicycle, and the hypocycle, and send them over the weekend. Alright? But here's what we have to do, because remember, this you just said is the big circle. Let's highlight it. Let's put it as an object. There we go. Alright? The hypercycloid rule is that the small circle must be under it. So it's not under it right now. So we need to move it before we can even create the path. So what you're going to do, select the divisions on the circle and select the small circle and type in move.
I'm sorry, I missed that. How much is the small circle?
Small circle was having a radius of 25, remember?
I thought there was a smaller circle inside it.
Oh, no. So follow me. This was the large circle, right? It had a radius of 75, correct? And we said hypercycloid must have it underneath the large circle. Underneath. But right now, is this small circle above or below it?
Above.
So we need to move it below it, correct?
Yeah.
Alright.
Yes, sir. How do I plot the points on the circle?
Alright. Or plot the points like this?
Yeah.
Okay. You're gonna type in first of all you're gonna create a radius line. Create a radius line. But just watch back the video for me because it's gonna explain it. But I just wanna get this across before we move along. So this we need to move underneath the large circle because that's a hypercycle. So we're gonna do select move, then select the highest point here, which is the point, and put it underneath here. Underneath.
Oh.
Yeah.
Okay, I pressed move and then enter.
So type in the command move, right?
Yeah. Type in the command move. Let me do it again one more time. Type in the command move. It's gonna ask you what do you want to move. Select the divisions on the circle firstly. Then select the circle itself.
Yeah.
Then press enter. Select the highest point, which is right here. Then drag it down all the way down to right underneath the large circle, because that's a hypercycloid. Right, let me see. Excellent. Right, excellent. Okay, good. All right. Now the next thing is that really, let's look at if ours is similar to the man. No, let's look at it. Let's see if it's close to it. All right. Go here. Fast forward a little bit. There we go. It does look like it now. All right. So there's our circle and there's our curve. All right. And what we did with the large divisions, we didn't have to go that far, but here's what. We already finished here, because all we can do now is to say this shares the same division here, so we don't have to delete up here even, because it's the same thing. Understand?
Yes, sir.
Right, we don't have to delete it because it's representing the same division. All right, then now let's look at the next step. We already have our angle. Our see he drew it through. Let's do that. There we go. Okay. Now after class you're gonna label it for me, but for now, let's just finish wrapping up by just drawing the smaller circle on the base. So here's how we do that. You're gonna type in circle for me. Go on your construction layer. Go on your construction layer. There we go. Circle.
So type in circle.
Yeah. Then go to the.
This is where I'm at, sir.
All right. Let me look on your screen. All right. Good. So all right. So Delano, what you're gonna do now? All right. You're going to, so what's your base circle? Which circle is a 75 millimeter radius? That one?
Yes, sir, that one.
Alright. So now you're gonna use that point to draw a circle inside of it. So let's look at mine. So if that is your 75 millimeter radius, look at what you do. You're going to go inside 25 and then draw a circle touching that point. Let me highlight this. Let me put it in a different color just so you understand what I'm saying. You can change the color too, guys. No, you can design a thing. So there we go. And then put it in our object layer. There we go. Right? So if this is just 75 millimeter line, circle, you're gonna go 25 millimeter in, right? And then draw a circle to touch the edge of that. Understand? Alright, so let's get back to it now. The next.
Wait, sir. So I'm gonna go to the 75 millimeter line.
Yeah, right here. So go to the edge where it stops, right here. And you're gonna go 25 millimeters in.
Okay.
And then draw the circle.
So wait. So sir, what's the next circle after that? What's the radius of that circle?
This one? Oh, this one above here?
Yes, sir.
That was an example to test to see if you guys were paying attention, because what I was drawing there was an epicycloid. And I wanted someone to correct me to say, sir, that's not hypercycloid. But it still applies because it's the same divisions here. Alright. But the next step we have to do, guys, is to wrap up by putting another curve right here. So what we do, we just type in circle. Use this point right here. Alright? And then we're just gonna go into each division. So let's say division 1 right here. My bad. Same thing that we did for epicycloids. Division 2 right here. And we're going to create a special division for the center line. So first we go to the center line. Then we color it using red or blue. So we go to my center line is going to be red. Here we go. Then we go to the last point. So remember, you have to label yours because or else you're going to get confused. So let's label yours after class and you'll easily get it.
So we should label them with different colors?
Yeah, or label them just by 1, 2, 3, 4. So you would start to count counterclockwise. Alright?
So I'm not sure how to do that. How to change the colors of the
let me show you. So for example, what if you want to color this line blue? All you have to do, go select the line and go to properties and then change the color right here. So go to properties and you're gonna go right here, change the color to, for example, let's select peach. Yeah, there we go.
Okay, sir.
Good. So you never get confused when you're drawing. Okay. Next step now is to create the final enclosing circle, which will be the base point right here. There we go. And now, what's the command that we use to really clean up the circle so we only have what we need? Starts with T.
T.
Trim, correct, trim. So we're gonna select that and this final line, and we're gonna type in trim, really, and then just clear up everything that we don't need. Excellent. There we go. That's my favorite command. It just gets rid of everything easily. Alright. So now, a next trick you can do, let me teach you. What if you still want to have these lines but very faintly? Let me show you. In a spirit, you can even play around with this. Let me show you. I don't know why this is so small, but let's see what you're gonna do. You're gonna go on your construction line and look for transparency. You can turn it up to, like, for example, 90, and it looks so faint, but it makes the drawing look so neat. You see that?
Sure. Thing that was like glitching for like the past 2 minutes, and like I completely missed like half of the stuff.
All right, never mind. So just watch the video back. Just the time is now. So watch 10 minutes before the video ends, and then you understand it.
Okay.
Yeah. So you see how this looks very neat now, because I made the transparency very very low. 764. External 764 425. Alright, there we go. There we go. Let me show up my screen. I can tell this is one of your favorite classes. I can tell. 110.
Any class I joined back for.
Wait, here we go. So let's say, for example, you want your drawing to look this neat. All you're gonna do, right? It's gonna go in layer properties. Go to your line type and just look for transparency. So here we go. Here's transparency, and you can turn it up. So let's put it at 95 and let's see how it looks. It makes it look especially neat. Let's put it at 95. Oh, it must be a range of 0 to 90. My bad. So let's put it at 80 and let's see how it looks. Right, there we go. But I want it to be very faint, so I'm gonna put it back at 90.
So remember I was telling you that I don't see those, and remember I was telling you.
So all right, so here's what I'm gonna tell you. Like, I'm gonna give you a piece of a spreadsheet that tells you all the commands that you should have, but you can just type it in.
Okay.
Yeah. So for example, if you want to look for what I just did, you just type in layer P. There you go. Well, let me just admit everyone else. I think they're in the waiting room. Disable waiting room. Okay, so let's just wrap up quickly. Now the next circle that you need to highlight is the base point right here. So we're gonna highlight that as our main line, object line. There we go. And now the fun can begin. So all you're gonna do now is literally copy this circle using the different center points. And as you can tell, I haven't labeled mine, so it's very hard to see. But let me just put a donut for each center point. I'm gonna put a donut there. So I'm specifying the inside as 2, the outside as 5. There we go. The first center point is gonna be where the line touches the red line. There we go. Alright, my bad. Google thinks I was talking. There we go. Second one right there. So essentially, you're looking for wherever these divisions touch the red line, and those are your center points. Alright, and when you do that now, you can just repeat the same step that you did for cycloids and get the curve. Then that's your task over the weekend.
Alright.
But here's the fun thing. I think I'm just gonna give you this drawing, right? And then you can edit it. How about that? And then yeah, so I'm gonna give you this where I reach. Your task is to edit it, and the person who designed it the best gets 5 points on the leaderboard. Alright, let me finish this. Right, there we go. So your task is just gonna be to label everything, right? Detail the title, everything, and get the curve. And then the best one is gonna get 5 points on the leaderboard. That sounds good?
Yeah, sounds good.
Alright, I'm gonna save it. And it also has the parabola that you were supposed to do, but here's what you can do. Literally just write a few sentences explaining it, and then just change around the lines, and I'll say that's yours. Sounds
okay.
Yeah. Just explain to me in a paragraph how I got it, right? And then just make it look like your own. Like, for example, change the line color, because it's the same steps. It's not really a case where I need to have individual. Just change the line color, for example, to green or something, and just explain to me how I got it, and then I'll mark it as yours. All right, let me save it, and I'm gonna send it to you guys now. All right, that's the end of class. Any questions?
No.
All right, enjoy the rest of your day.
Bye, sir.
All right, take care.